Okay, today we're going to start talking about inverses. This is a review of some stuff we did with linear functions. We got to talk about inverses of quadratics because it's actually pretty interesting. Okay, so let's review quadratic functions real quick. For the equation y equals x squared, complete the table, then plot the points to construct the graph. Okay, so if we're talking about the equation y equals x squared, what does my table look like? What is negative 3 squared? 9. What's negative 2 squared? What's negative 1 squared? 1. 0 squared? 1 squared? 2 squared? 3 squared? 9. Good. Okay. So let's plot it on this graph right over here. Negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2, negative 1, 0, 0, 1, 1, 2, 4, and 3, 9. Can I connect these dots? How do you know? And don't say because I already did. How do you know? We have an equation, right? We have an equation. Okay? So if the domain of this function is negative 3, negative 2, negative 1, 0, 1, 2, 3, then what? What's the range? If this is the domain, what's the range? If this is the domain, what's the range? It's the y's, so what is it? Why do we write it as 0, 1, 4, 9 and not 9, 4, 1, 0? It's in order, right? We put it in order from least to greatest. Greatest? What does that even mean? Greatest. Okay, so is this equation a function? Yes, explain. Yeah, that repeat. Very good. No x's that repeat. Why didn't I just write yes, no x's repeat? It's not a complete sentence that way, is it? Good job. Okay? Ask me. Because we're talking about specific ranges, it gave me a specific domain. So I can't just put y is greater than or equal to 0 because it wants the specific range that went with this domain. If on the domain it said x is greater than or equal to 0, then I could put, well, if x is only greater than or equal to 0, it's only talking about that side, right? So we just have to be careful. Okay? Okay, so far, everyone? Okay, look at number 2. Inverse with coordinates. Recall that an inverse can be found by switching what? Would you remember that if you couldn't just read it? Okay, do you remember when we did inverses first time? How many times did I make you repeat that to find an inverse you switch x and y? 87 times. No, I just totally made that up. A lot though. Didn't we repeat that a lot? Okay? I really need you to remember that because guess what? It's coming back. We have to talk about inverses again. A lot of the stuff we do, we don't just talk about one time and forget it. Okay? So we switch x and y to get the inverse. So use this method to make a new table for the inverse of y equals x squared. So if these are the x's, if this is the domain, how do I find? Excuse me, if these are the y's or the range, how do I find the x's or domain? I'm just flipping these two tables, aren't I? This is becoming this one, this one's becoming this one. So this is 9, 4, 1, 0, 1, 4, 9. And now we need to graph it over here. So when x is 9, 2, 3, 4, 5, 6, 7, 8, 9. Y is negative 3. 1, 2, 3, 4. Negative 2. 1, negative 1. 0, 0, and then 1, 1. 4, 2, and 9, 3. Is this a function? Say it again, Emilio. So is it a function? No. There are x's that repeat. So how could we do that with, like algebraically, how could we do it with an equation? How could we find an inverse with an equation? If we find an inverse of a table by switching x and y, how could I find it with an equation? Switch x and y. Excellent. So this used to say y equals x squared, and now we want it to say x equals y squared. Perfect. How do I solve that equation for y? For the new y? I have to take the root of both sides, don't I? Here? Okay. So y equals the square root of x? Correct? What is this down here? What's that little baby 1? Is it an exponent though? See how it's with the f? That's just saying, hey guys, this is an inverse. Okay? We're not having to do anything with it. We don't mess with it at all. It's telling you, hey guys, this is an inverse. So the new function would just be, hey, this is an inverse, and it's the square root of x. Okay? Use a calculator to help you sketch the graph. Well, let's see. First we have to turn our calculator on, right? That's important. Menu. We can make a new document. We could use the scratchpad graph, right? Regardless, when we go ahead and put it in, it's going to look like this, isn't it? Did I do something wrong? Because those two things don't look alike. Do they look alike on yours? Do they look alike on yours? No. So does this match your answer from number 2? Do these two match? No. Explain. There is no... What? There's no bottom half. Can you see how compare this one to this one? If we look at this graph right here that we just put in the calculator to say the square root of x, there's no bottom half. Why is that? Can my calculator graph things that are not functions? Not the way we have the calculator set up. Okay? Not in the mode that we have them in, the one that we work with all the time. Okay? Any questions so far? Okay, so let's do just a little bit of exploring there. Okay? So here's the first one. What's the equation of this graph? Excuse me. Y equals x squared? Right? What shape is that? Parabola. Can I ask you to be a little bit more specific? Vertical. What do I mean by vertical parabola? It opens up or down. Okay? This one, in fact, opens up. So, what are the properties of inverses? First of all, their graphs are blank over the line blank. Reflected, very good. Over what line? Do you remember? Y equals x. And their equations, their graphs are reflected over the line y equals x. What's true about their equations? What switched? So, x and y. So what does its graph look like? What's the equation for this? X equals y squared, because you just told me the x and y are switched, right? What shape is this? Oh my goodness. A horizontal. Oh, if I spell it right, that would be good. What's the problem with this graph? Not a function. Now, guys, don't get me wrong. We're going to study things that are not functions because there are graphs that are not functions that are quite important. Okay? But in the beginning of Algebra 2 and even up to now, we're not studying things that are not functions. Okay? So when this happens, we normally just graph the top half. Very good. And we call it the square root function. Here's the table. When we graph this, it looks like this. Whoops, ignore that little bump. What is the domain of this function? What x values are allowed? Only 0, 1, 4, and 9? All real numbers greater than 0. How do I write that? X is the little sign. How about that one? Wait, is it just greater than or is it greater than or equal? Equal to 0. So you can only use positive values for x. Very good. Well, if that's true, then what is the range? Y is greater than or equal to 0. Very good. Because you will only get positive. Geniuses. Okay? This is a pretty important page for us, especially this part right here. Okay? This is a pretty important page for us because aren't we really talking about the parent functions of the square root function? Okay? We're really talking about the parent function here. This tells you the domain and range, the graph, and what it looks like. The table looks like. Okay? So for homework tonight, you're going to do 4, 5, and 6. 4 is similar to 1. 5 is similar to 2. 6 is similar to 3. So look back if you need to. They are slightly different though, so just be careful. Okay? Now look at the transformations page, please. This is the one that you're already really good at. Okay? This is the one you're already really good at because we've already done it. We've already done transformations, right? Okay? So let me show you how good you are at it. What we have to remember, what we have to figure out and remember is we used a lot of when we talked about quadratics, we used a lot of terms like inside and outside. Are we still going to be able to use terms like that here? Do we have something to be inside of and outside of? We do, right? We have the square root function, or the radical, right? Okay, so we just have to know what it looks like when we're talking about square roots. Okay, so here's the parent function. We already knew that because we just looked at it just a second ago. We know it starts as 0, 0 and like that, right? It's like the top half of a parabola if it was a parabola laying on its side. So if we're talking about this function right here, the square root of x plus 3, tell me if this 3 is inside or outside of the radical. How do you know it's outside? Because it's not covered. Are you okay with that? So where is that going to move compared to its parent? If something's outside, where does it move? Up or down? And this one says plus 3, so it's going to move up. When we talked about transformations of parabolas, we started at the vertex, and we moved the vertex around, and everything else just kind of followed. What do you think we're going to move around for a square root function? How about the endpoint? Okay, so if I'm moving this up 3, isn't that where it is now? Okay, I'm going to finish this video so you have it for tonight, because you definitely need this page right here filled in, and then the 6 problems on the back are your homework. Okay, so the 3 problems on the other page and the 6 problems on this page. Okay, so if we start here, if this is our endpoint, up 3, then we have to draw 1, 2, 3, 4. We have to draw our parent just shifted up 3. So our new endpoint is at 0, 3. We moved left and right none and up 3. So how does this compare to our parent function? We moved up 3. Okay, I know you know the correct vocabulary right now. We just need to get it written down. Okay, so this one is also outside. So we know it's minus 3, so it's going to move down 3. So it's 0, negative 3. This one's on the inside. It's on the inside, so it's going to move opposite of what direction we think it is. So it's going to move left 3. 1, 2, 3, 4. So this one's actually looking like that, and the endpoint is at negative 3, 0. Oh, we forgot to write this one. How does this one move? It moves down 3. This one, how does it compare to the parent? Moved left 3. Okay, this one right here, x minus 3, it's on the inside, so it's going to move opposite of what we think, because we'll talk about that in just a second. 2, 1, 2, 3, 4. So like that. Okay, and it moved right 3, and our new endpoint is 3, 0. Okay. On this page is just a combination of inside and outside. It also has numbers like this, which are multipliers. It also has something like this, which hopefully you remember causes a reflection. So let me fill this page in for you right here with all the notes. Okay? So if we're multiplying something on the outside, if a is greater than 0, we have a vertical stretch. If a is between 0 and 1, we have a vertical compression. If a is less than 0, that's going to cause a reflection. We have to remember that it's causing a reflection over the x-axis. If something's on the outside, if we're adding on the outside, adding k translates the graph up, subtracting k translates the graph down, and the last thing we have is the h. We're adding, though, this time on the inside. Okay, so adding h translates the graph adding h. So if it looks like x plus 3, for instance, it's going to translate the graph left. It's inside, so it's opposite of what we think. If we're subtracting h, so if it looks like x minus 3, we're going to translate the graph to the right. Okay? In a situation like this, this is opposite of what we have been doing. Okay? Before I gave you the equation and asked for the graph, I gave you the parent to compare it to. This one gives you the graph and asks for the function rule. Okay? Hopefully you can tell that this one has been shifted up some and it's been reflected. So when we go to write the function rule, we're going to have y equals. We start off that way. It is a reflection, so we have a negative. The square root of something, it's only moved up 1, 2, 3, 4, 5. Moving something up is the k value, so that's going to be on the outside. So I have the square root of x plus 5. Okay? Here, we're stretching the function. Can you tell it's stretched? It's taller than the parent function. It has moved to the left 3. Okay? So hopefully you can see that we would start with y equals. Yes? Start with y equals. And this shifts, like I said, to the left 3. So that's going to be on the inside. So it's going to be x plus 3 on the inside. Now, how much did it stretch? Normally I go over 1, up 1. This time I went over 1, up 2. So how much further up is it than it was before? It's twice as far up as it was before. No other transformations took place, so that's the function rule. Okay? So you have problems 1 through 6 on the back, and then you have problems 4, 5, and 6 on that other page. Okay? I hope this helps, and I hope you have a great day.